Good morning or afternoon, Algebra 2. So today we are going to continue with special right triangles, and we are going to talk about the other kind of special right triangle. And so if you flip to the next free page in your notebook, so we're still talking about special right triangles, but we are going to be talking about not half squares. So we're not going to be looking at 45, 45, 90 triangles. We're going to be looking at a different kind of triangle called a 30, 60, 90 triangle. So go ahead and flip to the next free page in your notebook. You're going to title it really quick. And I know you might need to pause it, but I'm going to kind of keep moving on. So here is our second special kind of triangle. So for this triangle, remember our 45, 45, 90 came from a square. So this particular triangle is going to come from an equilateral triangle where all my sides are equal. And I don't know if you remember, but if all the sides of a triangle are equal, then all of the angles are equal as well. And since an entire triangle, each of the three angles add up to 180, if all the angles are equal, and if they all add up to 180, then 180 split evenly into 3 is 60 degrees. So each of those angles are 60 degrees. And if you're like, oh wait, there's a 60. Yes, it's a thing. So what you're going to do here, very similar to the square, is you are going to also chop this triangle in half from top to bottom. And we are going to ignore one side. So we're just looking at half of an equilateral triangle. And if we zoom in on this triangle, we're going to discover a couple of things. So one, I just cut this angle up top in half. And so it was 60, but now that angle right there is 30. Excuse me, sorry, a lot of that today. 30 degrees. And so that is actually where our 30 and 60 come from. And then because we cut it in half vertically, our last little angle down there, that's our 90. And so if we kind of zoom in, or at least kind of take that away from the rest, a couple of things are going to be true actually about the sides of the triangle as well. And so let's say that for our original triangle, the sides, since they were all equal, let's say that they were all equal to 2. That means that this side was 2, this bottom side, the whole thing was 2, and then this side was 2. And so actually we'll just go ahead and put a 2 right here because we're sort of taking this chunk off and leaving it down here. Well, if this side was 2, I now have split this bottom side in half. And so now this side here is half of that 2, or 1. And then finally, I have this other side over here. And I don't know what it is, but I know 2 out of the 3 sides. And so I can go ahead and use a squared plus b squared equals c squared to find that third side. And I know from looking at my triangle, my C is actually the side across from the 90-degree angle. So that's my 2. And then my 1 is either A or B. It doesn't matter. I'll just stick it where the A goes. And let's just say this is B, because I don't know what it is. So solving this equation, I'll have 1 squared is 1 plus b squared, I don't know what it is yet. 2 squared is 4. And if I subtract 1 from each side, I'm going to end up with b squared is equal to 3. And if I square root each side, I will end up with b is equal to 3. Now remember, I want to try to simplify this as much as I can, but 3 is prime, so the only numbers that go into it are 1 and 3. And so even if I simplified it, the best I could do is 1 root 3 Square root of 1 is 1. Square root of 3 is still root 3, which doesn't really help me any. And so you can leave your answer as root 3, but we're actually going to use the 1 root 3 because it's going to show the pattern really nicely. And so if you look, you have the bottom short side is 1. The hypotenuse is twice as big as that bottom side, that's 2. And then the other leg, the longer leg, is that same number 1, but it now has a root 3 attached to it. And this actually is the pattern. That actually is the pattern for all 30, 60, 90 triangles. The base is always half of the hypotenuse, and it is always root 3 times the long leg. And so if you have this little half sheet here, we're going to start kind of filling this out a little bit. Actually, it's already partially done for you, but we're going to right now label this side and then we will glue it in. So again, this guy right here is my short leg, and we're going to start, no more ABC, we're going to just call that N. This is my short leg. And the way it works is whatever my short leg is, my hypotenuse is going to be double that length. So hypotenuse. And then my long leg, as you saw, is going to be the same value N, but just with a root 3 next to it. So just like your 45, 45, 90 triangles, there are patterns on patterns on patterns here too. They're just not as nice, I would say. Still workable though. Okay. So short leg, hypotenuse, and then our last guy here we're going to call the long leg. So short leg, long leg, hypotenuse. Okay, so how this works is I've actually given you your short leg, and I've given you your hypotenuse, and this guy here is going to be your long leg. And we've gone through and done the Pythagorean theorem part for you, and they're asking you to simplify, but I'm just going to tell you to kind of use the pattern. So 2 times 2, double 2, would be that 4. And so that's why your hypotenuse there would be 4. I'm just going to actually draw this triangle. So this little guy, it's saying that the base here is 2. It's saying the hypotenuse is 4. And so this leg, if you simplified it, would be 2 root 3. And so that's what would go here. And then you could redo this for each of those triangles. So this one would be 3 root 3, 4 root 3, etc. And then the pattern is this would be N root 3, and then these are always double. So 2 times N. Okay, so filling that all in, we have for any 30, 60, 90 triangle, the hypotenuse is 2 times the short leg, and the long leg is equal to root 3 times the short leg. So it's all based on that short leg. Okay, so what I'm going to have you do right now is I want you to go ahead and glue this into your notebook, and then we're going to continue looking at some examples with that after you're done gluing that in. So feel free to pause, glue it in, or if you want to just keep going, we can keep going as well. Okay. So I will go ahead and keep going, but please pause and glue that in and leave space for it. Okay. I'm going to flip my page. And so I'm looking at a new page, and we're going to go ahead and keep going. Okay, so we are now going to find all missing sides of each of the triangles below. Okay, and we're going to look at 5 examples total. So I'm going to go ahead and draw them, draw 2 of them, and then we'll talk through them. And by the way, if at any point you're like, I totally know how to do this, then do them. That's great. Okay, so our first 2 you're going to go ahead and label this side with 7 and this side with 12, or label that 60, or label this guy 30. And then we'll draw one more. Ooh, bumpy triangle. And we're going to label this side 14 root 3. Okay. So we have 3 30, 60, 90 triangles. And if you're not sure how you know, if any of the angles are labeled 60 or 30, then they must be 30, 60, 90 triangles, because if you added up 90 and 60, you get 150. And if you subtract that from 180, that would mean this has to be 30 degrees. And then vice versa. So if you had 30, this last angle would have to end up being 60. Okay. So I know that my little pattern is whatever this n is, that bottom side. The hypotenuse is 2n, and then my long leg would be n root 3. So I'm keeping that in mind as I'm looking at these triangles. And I notice the first thing I'm going to look at is what I am given. And it looks like here I am given the short leg on number 1. On number 2, I notice I'm not given the short leg. I'm actually given the hypotenuse. Oops, hypotenuse. And then for my third triangle, this is my short leg. It's not really my hypotenuse either, because my hypotenuse would be there. So this must be my long leg. And so my goal, my game here is I look at what I'm given and I solve for the things I am not given. And so we'll start with number 1. So I'm given that the short leg is 7, and that's kind of nice because the rest of these are all based on that short leg. So if that is 7, for example, I know the long leg has to also be 7, but with a root 3 next to it, because these two are both long legs. So long leg, long leg. And then this guy up here must be 2 times that number, because it is a hypotenuse. So 2 times 7 is equal to 14. So I have 14, 7, 7 root 3. And I got each of those. Ooh, why are we not focusing? There we go. I got each of those by following that pattern here. Okay. So this time, and feel free to pause this and try these yourself if you're like, nah, I got this. This time, you were not given the short leg, but you were given the hypotenuse. And so I'm going to this time go ahead and start with the fact that I know the hypotenuse has to be double that short leg. So I am going to go ahead and divide 12 by 2. And you don't have to actually write this out. If you can do this in your head, please do. It will save you a ton of time later. And so I notice that this short leg value is 6. And so this guy over here appears to be shorter. So this side must be 6, which means that my long leg must be 6 root 3. So my hypotenuse is 12, my short leg is 6, my long leg is 6 root 3. Okay. All right, so I have my last guy here. This is my long leg. And so I know my long leg has to be equal to that n root 3. So 14 root 3 has to equal n root 3. And I see that n must be equal to 14. If you were doing this mathematically, you could also just divide by root 3, divide by root 3. Those would cancel, and that's how you end up with n equals 14. But you can just look at those two and realize that the short leg must be 14. So that means 14 must be my short leg. And then for my hypotenuse, that has to be double my short leg, which in this case is 28. Okay. So that's pretty much the process. That's how this goes. As always, of course, these do get a little bit worse. And so we're going to look at a couple of these that don't look as nice, and then we'll be done. All right, so two more. So number 4, we're going to look at similar looking triangle because they're all the same shape, 30, 60, 90. And this time we are going to start with that side being 12. And then over here, similar type of triangle, that side being 10. Okay. All right. So I have these 2 new triangles and we're going to keep going. First, what I'm going to do is I'm going to again label each of these sides and figure out what I have. So it looks like this side is your hypotenuse. It's across from the 90. This side is our short leg, which means the side we have must be our long leg. And so that means actually that this 12 must be equal to n root 3. Okay. But if you're noticing, that 12 doesn't have a root 3, and you're absolutely right, it does not. And so very similarly to how this worked for 45, 45, 90 triangles, we're going to kind of do the same thing. And there are shortcuts on shortcuts on shortcuts here. So I'm going to go ahead and divide out that root 3 to get n by itself. And so I end up with n is equal to 12 over root 3. But if you remember, I am not allowed to leave a root 3 on the bottom of a fraction. So I have to actually multiply top and bottom by root 3 over 3. And so when I do that, I don't know if you remember, but lots of stuff are going to cancel and you're going to end up ultimately very similar to how we did this with the root 2's. You're going to end up with 12 root 3 on top, and then these 2 on the bottom are just going to turn into the number 3. That is how this works every time. Because root 3 times root 3 is equal to root 9, which is just equal to 3. But if you can go ahead and skip straight to that, that would save you a ton of time, and this would be much, much easier. Okay? And then finally, just like before, if you can divide these 2 numbers, you need to. And so if you do divide those 2 numbers, 12 divided by 3 is actually 4. And so this ends up being 4 root 3. And in case you're like, well, what did we just do? Why did we do that? Remember, we're given the long side. I want to start at least by finding that short side. And this is how I do that. And so I actually just figured out that the short side is 4 root 3. So I have 12 and I have 4 root 3. Lastly, my hypotenuse is equal to 2 times my short side. So in this case, 2 times 4 root 3. And then if I'm multiplying numbers like this, just a normal number and a number root something, you're just going to multiply the 2 numbers outside of the root, which will turn this into 8 root 3. And so my 3 sides are 12, 4 root 3, and 8 root 3. Okay. So our last one is the same. It just has a different number on the outside. And again, feel free to pause this, rewatch it if you need to. But this one, number 5, I'm actually going to do using a lot of shortcuts. And so if you want to see where these are coming from, they're really coming from what we did on number 4, but I'm trying to kind of do this quickly so you guys see how this goes quickly. So once again, I realize that, 10, this is one of my long legs. So that's a long leg. Here's my short leg. This is my hypotenuse. Okay. So I recognize that 10 should be equal to n root 3. I realize I need to divide both sides by root 3. And so 10 divided by root 3 is actually just going to end up being 10 root 3 over 3. And again, if you're not sure how we got from this to this, look back at the previous example, okay? Because it's the same process. You're multiplying both. I guess I'm writing it. Dang it. I'm not going to talk through it though. I have to multiply 10 root 3 times root 3 over 3, which is going to get you to this thing. So that's how we got here. Okay. So finally, if I can divide these two, I will, but I can't divide them evenly. So actually, this just is my short side. So 10 is my long side. My short side is 10 root 3 over 3. And then my hypotenuse is going to be 2 times that 10 root 3 over 3. And if you notice, once again, you're going to go ahead and multiply the two numbers outside of the square root, and you're just going to leave the number on the bottom as is. And so this will become 10 times 2 is 20 root 3 over 3. Lastly, if you now can divide those two values, you can go ahead and do that. But in this case, we cannot. So we're going to go ahead and leave it. Okay. So our three sides to our last triangle here are 10, 10 root 3 over 3, and 20 root 3 over 3. All right. So that pretty much is the lesson. And at this point, we're going to pause. Pretty much every problem you're going to see is going to be something like one of these. They don't really deviate a ton. So go ahead and pause this. Your notes should hopefully be caught up, and you can go ahead and start working on your Check Your Understanding assignment. Alrighty.